Is Martinez, and we are looking at trigonometry in the coordinate plane in this video today. Our objectives, what you want to be able to do, is to find the reference angle for any given angle measure, and then to find trig ratios for any angle in the coordinate plane using reference angles. So some new terminology here. Let's get started. When you have an angle in your coordinate plane, like you see here, and its vertex, the vertex of that angle is at the origin, that angle is in standard position. We're going to be working with these kind of angles for quite some time here, these that are in your coordinate plane. So this is an angle in standard position, and your angles have kind of like two parts to them, two rays. The ray that is on the x-axis, and that is actually coinciding with that positive part of your x-axis, is the initial side. It's kind of where your angle starts. It's where we're going to be measuring our angle from. And the other ray is called the terminal side. It's where your angle is stopping. So if you're starting at the initial side and then it opens, right, starting there at 0 and opening, that place where your angle stops is your terminal side. And the way I think about that terminal, that word, if you have terminate or terminal cancer or all those, what does that mean? That means to end. And so terminal side, that's where it's ending. Now you can have different types of rotations when you're in standard position. You could have a rotation like this, that is opening upwards like a clock, going, not like a clock, but going counterclockwise. That upward movement implies that it is a positive angle, because if you're going up, that's a positive motion. Now let me contrast that with this second one here. We are going down. We're going clockwise, and when you go down, that is going to be a negative angle measure. So if you start from your initial side and go up, measure up and over to your angle, that's going to be a positive angle measure. But if you go down and over to your terminal side, then that's a negative angle measure. Bit more terminology here. Okay, so if you can have multiple angles in standard position, and if they are ending at the same spot, their terminal side is the same, then they are called coterminal angles. In this diagram, which was just above, you have a positive angle, 160, measuring up and over, and you have negative 200, but they both end at the same terminal side. Both those angles do. And that is a scenario of coterminal angles. Now, you could have a lot more than just this scenario. Let's look at some more like this. Okay, so we're going to work with the angle, that theta is going to be 210 degrees. And we're going to draw that angle first of all in standard position. And then we're going to identify positive and negative coterminal angles for our theta. And we're going to write an expression so that you could find all the coterminal angles. So let's get started. I want you to take a moment and try to sketch out 210 degrees. Start at your initial side. Where, in what quadrant would that be? That would be in your third quadrant. If you go that positive y-axis, that would be, if you just go up to the y, that would be 90 degrees, right? Go 90 more degrees, that would be 180. And so you're going to go just 30 degrees more and that will give you 210 because 180 plus 30 gives you 210. Okay, so that would be a sketch of your angle, theta, which is 210 degrees, and it's in standard position in our coordinate plane. Now we want to find coterminal angles. We want to find angles that end at the same spot. Okay, well that just means really adding on rotations here. Just like if you were standing there and you were facing forward, you can make one loop and face forward, or you can make two loops and face forward, or you can go even the other direction and still, if you make a complete loop, you'll face forward, right? That's what we're kind of doing here. So if we just add a rotation, either positively or negatively, to our angle, then we'll have coterminal angles. We'll be ending in the same spot. So let's take 210 and add a loop, which is 360. That's going to be a full circle. That'll give you 670 degrees. So what does that mean? 210 and 670 are coterminal because they end at the same place. Another scenario would be 210 minus 360, and that would give us negative 150. I could even sketch that one in there right here. That is negative 150. It ends at the same place as 210. All right. Now, what would be a way of expressing all of them? Well, what we said just a moment ago, okay, it's just adding rotations, right? Either positive or negative rotations. So that would be taking 210 and adding any number of rotations. But this in right here, this in is going to represent integers. So like 1, 2, 3, or it could even be -1, -2, -3. Any kind of number of rotations, those whole rotations in the positive or negative direction will end you in the same spot here. So you'll have coterminal angles with 210 degrees. Okay, so that was coterminal angles. Now let's talk a little bit more. I have a definition here. Let's say that we're given a point P and it has both an x and y value. And it is on the terminal side, so it's on your ray, in this case for your angle theta, that's in standard position. And your r is going to be kind of like the radius there, from your origin to the point P. You see how we're kind of creating like a little triangle there? And we want to find the 6 trig ratios for this general case. I know I don't have any values here. We're trying to create a definition, so we're working with an arbitrary point, meaning it could represent any point that has an x and y value. So how would we do this? Okay, well, sine would be the vertical component because that would be opposite of your theta over the hypotenuse, which in this case would be your y over your r. Cosine would be that horizontal component of that little angle there. So that would be right next to, that would be your x value over your hypotenuse. And tangent is going to be your SOHCAHTOA opposite, which is the vertical component, the y value, over your adjacent, which is going to be that horizontal side measure there. Now, the reciprocals would just be taking and flipping those values. All right. So it's really kind of most beneficial here to create a triangle so that you can really see, okay, if that is my point, what is the vertical component? What is my horizontal component? And then you'll be able to very quickly find your radius. That's really just using the Pythagorean theorem there to find that distance. Let's try this together. Okay, so first in this example, the first thing we want to do is we want to sketch the angle so that we can better understand this. So we're gonna do like we just saw. We're gonna find all the trig ratios for an angle. We don't know what the angle measure is, so you can't just like sketch your angle, but your angle needs to have a terminal side going through the point 5, -12. So here's what I want you to do. I want you to sketch that point 5, -12, and then draw a ray going through it. Take a moment to do that. Sketch the point 5, -12 in your coordinate plane, and just a rough sketch will do. You don't have to actually draw all your little tick marks, just a rough sketch. And theta is going to be that positive angle measure from your initial side to that terminal ray. Okay, so do that, and then when you're pause the video, do that, and then when you're ready, let's check it. Your sketched angle should look like this. The point P is at 5, -12. That means that the vertical component is -12, meaning that you went down. And 5 is that horizontal component that's over a +5. Okay, so we've sketched this, and we've sketched our triangle, and we've sketched theta, which is that positive motion all the way over to your terminal side. But what we don't know is we don't know our radius, which we really do need. We need that R value. So we just take our values, plug them in, solve for that hypotenuse. That would be 5 squared plus -12 squared. And then we take the square root of that. So that's 25 plus 144, which is the square root of 169. And we are in luck. That is, in fact, a perfect square. It is 13. So your radius there, that R value is 13 units. And then we apply our definitions here. Sine would be the -12 over 13, the y over 13, which is your hypotenuse, your R value, and its reciprocal, cosecant. Cosine was the horizontal, which is 5 over your hypotenuse, and its reciprocal, you just take and flip. Tangent was the vertical over the horizontal component of your triangle there, and its reciprocal. All right. Now, that was fairly simple because we were able to create a triangle, but there are scenarios when you sketch an angle and you can't create a triangle. That occurs when you're working with a quadrant angle. It's going to be when your terminal side is actually landing on one of your axes. So I want you to take a moment right now. Oh, yes, and their trig ratios may be undefined. The reason being is that your denominator, you could potentially be dividing by 0. So fascinating scenario here. We're going to look further into in our next couple lessons, but I want you to take a moment right now and sketch the quadrant angles in your notes and try and draw them with just a radius of 1 and state those 3 basic trig ratios for each of the 4 quadrant angles. So let your terminal side fall on one of your axes with a radius of 1, and we'll check those together. All right, so if you finish that, let's move on to your reference angles. If not, just pause this video and we'll get started on this in just a moment as soon as you're ready. So reference angles, what are they? when you're working with anything but what you just drew, you're going to have a reference angle. And what it is it's the acute angle that's formed by the terminal side of your angle and the x-axis that's going to be just above or below your terminal side. Let me show you here. So say you have an angle and your terminal ray ends in your first quadrant, like this one. Alpha, your reference angle, is just going to be from your terminal side down, that measure, down to your x-axis. So that's marked with a little alpha there in green. Say you end in quadrant 2, like this one. Okay, so again, you're just going to measure from your terminal side down to your x-axis. It's essentially that little angle inside of that triangle. Now that triangle actually has a name. It's called a reference triangle. Suiting, right? It's the reference angles triangle. Okay, what about if you end in quadrant 3? Here our terminal ray is in quadrant 3, so alpha is just going to be the angle up to your x-axis. And there's our nice reference triangle. And lastly, if you had an angle ending in your 4th quadrant, you would measure up to the x-axis. Now I want you to like highlight, make very, very certain that you are measuring from the terminal side to the x-axis. X-axis. Not the y-axis, the x-axis, which would be just above or below. You're not measuring side to the y-axis, just to the x-axis. Let's try this together. We're going to find the exact values, meaning we're not going to use our calculator here. We're going to give exact values. We're not going to round. We're going to give exact. Radicals are appropriate here for an angle theta, which is 210 degrees. So the first thing we're going to do is we're going to sketch this angle and find its little reference angle as well. So take a moment to do that. Sketch 210 in that little coordinate plane. Where is it going to be? And where will its reference angle be? Make a nice clean sketch. Here's mine. 210 is just 30 degrees past your x-axis, which conveniently is my reference angle. I'm measuring up to that x-axis. That is my alpha, my reference angle. Now we need to label the side measures. Well, how do I know what my side measures are? Okay, this is a special right triangle. It is a 30, 60, 90 triangle, and in our previous lesson, we saw that for all 30, 60, 90 triangles, they have a side measure. Their sides all kind of have the same proportions. Opposite the 30 is the side that is 1 unit long, but in this case, because we go down, we're in our 3rd quadrant, that's going to be a -1. The hypotenuse is 2, and well, it's distance, so you can't have negative there. And the other side is the square root of 3, and again, because in your coordinate plane here, where your point would be located is negative. It's a negative x movement, so that would be a negative square root of 3. If this is not at all familiar, just go look back at your last lesson. We looked at the 45, 45, 90 triangle, as well as the 30, 60, 90 triangle, and you'll see these measures. Okay, so now the 3rd step is just to apply our definitions. Sine is going to be, sine of 30, that would be opposite, which is the square root, which is -1 over the hypotenuse, which is 2. Cosine will be adjacent to 30, which is negative square root of 3 over your hypotenuse, which is 2. And tangent will be SOHCAHTOA O opposite, which is -1, over the adjacent, which is the negative square root of 3. Okay, so we can't leave that answer with a radical in the denominator. That will give us square root of 3 over 3. The negatives have canceled out, and our final answer would be the square root of 3 over 3. All right, so that is finding exact values using our recollection of these special triangles to be able to figure out proportions for our sides and give those trig ratios. So you have an additional notes section. If you had questions, make those. If you had concerns, put a little question mark next to the part that was concerning to you. Make a note so that we can go through those together and I can help to clarify anything that was not made clear. And it's perfectly normal for things to not be clear the very first time. That's why we keep practicing. All right, so that is all. Signing off. See you soon.